Hello, I'm Justin, and I'll be talking briefly about designing a data capture module for TI's millimeter wave radar sensors. Today, radars have been miniaturized and are now available in tiny packages. For example, pictured here is the development board for the IWR-1843, one of TI's high-frequency millimeter wave radar sensors. So these radar sensors integrate a full processing chain ranging from the analog front end all the way to a digital signal processor. Conventionally, object information is computed based on mathematical models of how the radio waves behave, which works well enough for many applications, but still has room for improvement due to issues like multipath propagation, where the same transmitted radio wave might reach the receiver at different times due to interaction with the environment. As such, researchers are now interested in using alternative techniques like deep learning to process the raw data directly to compensate for these limitations and for more complex applications like object categorization. To facilitate this research, the raw data has to be transferred to another computer, which can be challenging because of the high bandwidth requirements. Right now, TI provides a FPGA board and the corresponding software suite to receive high-speed radar data from the sensor. However, the closed-source firmware limits its customizability and presents issues when trying to integrate the radar into an application. As such, this project uses an alternative, more powerful system-on-chip that integrates both an FPGA and a few ARM cores to develop another data capture module. So this is the brief overview of the implemented data capture module using the AXU2CGA development board for deserializing and streaming the LVDS data over Ethernet. Firstly, an adapter was designed and fabricated to convert between the coax cable from the radar development board to the 0.1-inch shaders on the FPGA board. Then, a module developed for the FPGA handles the deserialization and frame aligning of LVDS data from the radar. The data is then transferred to the processing system, where a web interface has functionality like configuring the radar and also displays debug information from the radar and LVDS transfer module. This interface can also be used to stream data. For example, radar data could be streamed using a Python script running on a PC for visualization and further processing or storage. In summary, advancements in technology have made available compact, highly integrated radars. This has led to growing interest in developing new methods for processing radar data, which requires access to the raw data directly. Current tools for such transfer are limited, which this project aims to address by developing another data capture module. One possible further extension of this module would be to utilize the ARM cores directly as general purpose compute. So for instance, machine learning applications could run directly on the board rather than on a separate PC.